Okay, good afternoon everyone. My name is Kevin. I am an 11th grader at Plano West Senior High School, and today I'll be talking about innovation without limits. So the goal of my talk essentially is to communicate a new and perhaps interesting perspective on innovating without limits, but at a pre-collegiate level. So without college or professional experience, how you can leave your mark on the world and your community. All right. So what you're looking at here is a flow. Most of my talk is going to be based on concepts from science fair. It's a competition. It's basically an innovation competition that goes all the way from the school level all the way to the international level. And so in these contests, students basically find an idea, they find a problem in their community, they want to solve it, and then they present it to judges. So as you see here, white space identification. Mr. Jetley did an excellent job at explaining some white spaces that there are in our world that could be patched. So you find your white space, you design an idea to solve that problem, you develop and test your idea, and then you present it, you wrap it up, and then you pitch it to investors or judges or whoever you need to. So this graphic right here is pretty much the extent of the theory that I'll talk about today, because what I want to do in this presentation is use a series of case studies, essentially my old projects, in order to explain where these ideas come from and how we can capitalize on them. So with that, let's get started. This project came all the way back in 8th grade, and it's called Smart School Bus Pro for Android. So what happened was, starting in 6th grade, I started riding the bus home, and what my parents would do was, they would call me all the time. At basically 3:30, they would say, "Are you on the bus? Are you on the right bus?" And then in the middle, they were like, "Are you on your way home?" And then when I got home, they would keep calling me, asking me whether I was home or not. And the reason that they did this was because of these news stories that they were reading. See this, the vicious circle of children left sleeping in hot cars and school buses. So these little kids are getting on the bus, they're really tired, they lie down on the bus so that they're not visible to the school bus driver, and then they fall asleep. When the bus driver gets to their stop, they don't get off and the driver doesn't know, and then they're left there. And especially on a hot day, this bus functions like a greenhouse. It traps all the heat in there, and then this can lead to fatal tragedies. And so, that's just one of the many problems. If you take another look here, students lost on first day of school, people getting on the wrong bus, people getting off at the wrong stop. There are just a whole slew of issues with our modern school bus system, especially for younger students who are not necessarily maybe as aware of their situations. So, what my application aimed to do was to solve this problem with a software application, an easy to use look and feel software application for these smartphones that a lot of people now have that provides a bunch of features. So the first module of feature is monitoring, so parents can track their students with a GPS, and in fact, you know, the temperature is getting colder and colder, so if you don't want to stand outside waiting in cold weather for your bus, you can look at the location of your bus while it's coming so you can get outside right as the bus arrives to minimize the amount of time that you have to suffer. And so that's the monitoring system. The alerting system basically is a fail-safe for what happens when things go wrong. What happens when a student tries to board the wrong bus, disembark at the wrong stop, or if there are any students remaining on the bus when the driver is gone. And finally, record keeping for the district to keep tabs on actions. So what this culminated in was an application that you can see I made a video for that I developed, and then I pitched it to science fair judges. So even though I had been doing science fair by this time, all the way from first grade up until, at that time, 8th grade, this was really my first, I don't know what you would call it, a big break in science fair, because the judges seemed to kind of like it. So at the school level, I advanced from there. At the regional level, I was unable to get grand prize, but I got a placement high enough to move on to state, and then at state, I just don't know what happened, a bunch of luck overtook. And then I ranked first in software, and then first in physical grand prizes, and then out of all the grand prizes, best in show. And so the purpose of this application really came out of nowhere. I didn't make it to get money. I didn't know anything about money at the time. I didn't make it to boost my college application. I was in middle school. So the whole inspiration behind this project literally came out of me being annoyed at my parents for calling me all the time, and rightfully so, because they were worried for my safety. And so, remember that I wanted to use a couple of case studies to maybe show a couple of virtues of innovation that I wanted to communicate. So with this project, my virtue then is innovate to impact. And another part of this is that you don't need advanced technologies to make an impact in your community. Take a look at this. What do you think this is? This looks like a children's toy, right? They look like Legos that you piece together. So what this actually was the code behind my project. You think of a software application and you think of these huge black, screens of colorful text on black background, the coders. But this is actually not what happened in my project. You don't need these advanced technologies. I was literally playing with blocks, even though this language, MIT Inventive, might not have been as expressive as other applications like Java for Android and Swift for iOS. They were totally sufficient to build an application that could leave an impact on the community. So just remember this, innovate not for fame, not for money, but actually just to impact. The rest will just come with it. All right. And so moving on, I entered high school in 9th grade, and this was my project. So what happened was, between the summer of 8th grade and 9th grade, I was approached by this guy. He was a small business owner, and what he told me was he had heard about my other project from 8th grade, and he said, I've got a problem. So I have a bunch of products. I'm selling some bags for dog waste cleanup, or some toys for children. And I want to sell these through a bunch of different channels. Let's say Amazon, eBay, Overstock, Buy.com, whatever. So he had about 10 online stores. Now the problem with this that he said was, I have accounts, right, in each of these stores, and they can tell me, who's buying my products, what people are interested in, who's coming back, what is my customer retention. But he didn't have a unified solution. He said, well, I know for each individual store how my product is performing, but I don't know in general, a holistic view. So he said, I want this. I want transactions, what people are buying, inventory, where my products are, customer information, and marketing all in one place, a unified solution. And so that's when I came up with this. So you have all of these functional modules. You need transactions, you need marketing, you need inventory, and you need customer information. And so to integrate that over all of your online stores provides some kind of unified experience for this small business owner who can't necessarily afford more expensive softwares, and those don't even exactly accomplish what they need. And so I'll show you the application first. So this was the result. There was a dashboard. You could view overall sales, orders, inventory, and you could see when you needed to restock. And down here were little buttons that you could use to query different things. For example, who's buying my stuff? What kinds of products are being bought? And just a whole slew of different things, what SKUs are performing well and which ones are not. And so this one, in a natural progression from my MIT App Inventor colorful blocks days, I started to use a little bit of a more, advanced technology, maybe that's what you would call it. So I use Microsoft Access. It's actually part of the Microsoft Office suite. You think Word, Microsoft, PowerPoint, Excel. Access is just another application in that suite, and it's extremely powerful. It's a database management software. So you have a bunch of data from all these 10 different marketing, from these 10 different stores. You put it all in a database, and then you can use SQL query language to query it. So I learned SQL. You can write queries, but the problem is just having these queries doesn't really do anything. You need an application to tie it together. And so that is where VBA came from, Visual Basic for Applications. It's a full-fledged general purpose programming language, and I used it to wrap it all together and build the app that you see right here. So from a natural progression to just needing the logic for MIT App Inventor to learning a little bit of syntax and perhaps algorithms, there's a progression here, and that culminates in this application that I myself was pretty content with, and I was pretty proud of it because when I showed it back to the person who requested it, he said, "That's great. So here's a paycheck for your work." And I was really excited because that was my first paycheck. And so you think things are going well until you reach judging. So I threw this into the science fair system again, right? So I go through the school level, I barely scrape through the school level. I get third in my category. I'm surprised, but I know that science fair is very variable. I move on. Dallas region. So the entire Dallas region, the science fair, I was excited. I go in, I talk to the judges, and then about 4 judges in, this guy comes up to me. He shakes my hand, he's like, "All right, hello, my name is XYZ. I've been judging for over 20 years. My alma mater is MIT. So immediately I'm like, okay, this guy might help. So I'm excited to pitch to him. I give him my pitch, I talk about it, and then at the end of the interview, he asked me this question. He says, where do you see this software project in 5 to 10 years? You know, so I tell him, well, I'm going to keep improving it, and since this small business owner liked it, I'm going to keep pushing it out to other people, and of course integrate more APIs once I have the opportunity to, for example, automatically sync this kind of data. And so he tells me to hold on. He's like, hold on. Well, I'm sorry to say this, but I think your software is going to be obsolete within 2 years. He says, there's no way that this is going to be successful. And so at this moment, I was actually very devastated because I put all of my work throughout the summer and throughout the school year, and this guy from MIT, who I respect not only for his education, but also for his involvement in science fair judging, he tells me that my project isn't good. And so that kind of leads into the second virtue, the one that I wanted to communicate with this project, and that is believe in yourself. I know you've heard it many times, but you don't understand. Well, you probably do, but sometimes we don't understand how important this is, because what other people don't see in you is what makes you special. I mean, you've heard those stories, right? The people who come up with these ideas we think are genius today, they were viewed as crazy. They were lunatics back in their time. And so it's very important to understand that whatever you're doing, you understand that you are laying the foundation for future greatness, and you should embrace that. All right, so after my first year of high school, freshman year, reportedly one of the more difficult ones, I came up into 10th grade. So throughout the 9th grade year, I met this incredibly intelligent guy. He's an excellent person. And what was interesting about our relationship was that he introduced me to a bunch of new technologies. He got me really, really interested in general purpose programming languages, for example, Java, C++, Python. Now what I did with these languages was he was pretty much the best you could find in high school informatics. So he could design algorithms and you submit them into contests and USA CO. So I got involved in algorithms contests, and then kind of as a byproduct of that, I got interested in machine learning. How can you not notice it, right? And so I began to realize how impactful that this technology could be. And so, naturally, as a natural progression, my next project was dealing with artificial intelligence. So what I did in this project was, I said this. So a lot of cars are now coming out with advanced driver assistance systems, right? You know, those lane departure warnings and forward collision warnings. But the problem with these is that they're reactive. So by the time that your car starts beeping at you that you're approaching this object too fast, it's too late to react. And pretty much half a second after, you're going to be hit, or he's going to hit you. And so the key to improving this time, they report that this is about a 5.5 second warning time. The key to improving this time is to know what drivers are going to do before they do it. Because if you know where drivers are going to go, for example, they're going to be turning left in the near future, you scan that area of interest for dangers, and if you see a danger, you alert them before they make the mistake that could cost them their life or the lives of many others. How did I do this? Let's take a look. So, you have these device sensors. Essentially what I was doing was I was monitoring the driver. You look at the driver, where he's looking and how fast he's going, and if he's accelerating or decelerating. All of these are indications as to where the driver is going to go in the near future. And if you think about it, this makes a whole lot of sense. So we need data about the driver. So I use 2 cameras, one that monitors the driver, one that monitors the driver's environment, and OBD sensors. If you guys are into cars, they plug into the bottom of your steering column, and you can monitor things like RPM, speed, and things like that, and a whole slew of other parameters. And I also wrote an application that you literally stick your phone on the steering wheel and then you spin it, and using a gyroscope, you know how fast it's turning in angular velocity. Of course, in which direction. And so with all this data, there's a need to extract some data, because just given a video, I can't do anything with that with a machine learning model. And so kind of the first stage of artificial intelligence arises, and that is to use feature extraction techniques to extract this kind of information from these videos. And so, for example, I can determine where the driver is looking. And so finally, with all this data together, I put it all into one huge feature frame. And what's important wanted to understand about this project was that it was a new problem, and so there wasn't a data set. You think of cancer data sets, you think of optical character recognition data sets. There are millions of samples all available online just for download, but since this was kind of a new problem, there was no data set for it. So I did create data, which means as one person, I don't have a lot of data. And then when you have so many parameters, I was sampling at 10 times per second, 10 hertz, 563 numbers in each frame. And so this is a whole lot of data, which leads to a whole lot of parameters for your machine learning model. And with a limited amount of data, it's a massive problem. It's a no. So that's where kind of the second stage comes in when I use another machine learning model to select the most important features. So I ask it, what is really influencing what the driver is going to do at the end, and use those. So I select the 12 most important ones, I discard the rest of the 551 features, and I move on. So I have a clean data set, and then I model it with this model called the recurrent neural network. Now what's interesting about this one is that it's temporal. So it considers not only information from this time right now, but also everything that happened before. If you imagine it, this makes a lot of sense if you think about it again. So let's take an example. So at time t, you're driving forward, no special circumstances. And then at time t plus 2, you look to the left. And then at time t plus 3, you start slowing down and you look right. And at time t plus 4, you look left again. So it's not only at time t plus 4 that you're looking left that I can make the deduction that you want to turn left, because that's simply not enough information. It's the accumulation all the way from t to t plus 4. So it really matters what happened before as well as what's happening right now. And so that's why I selected this temporal model. It goes all over from the beginning to the end of a time sequence. And so from that, I performed some evaluations. I determined that this was effectively able to predict driver's actions 2 seconds ahead, which I estimated would save 8,000 lives a year. And so what I did to kind of visualize what the model was doing, I created a simulator. So now you can see this model at work, selecting these 68 feature points on the driver's face and calculating the Euler angles to determine his head's rotation to describe it. And so that's where you know where the driver is looking. These two graphs represent the data that's coming in from the car, the OBD, and then these bars show the prediction. So what do I think is going to happen at the end of the sequence? So this project was kind of a bounce back year for me in 10th grade because I went from school, I did pretty well there, and at regionals, I totally did not expect this, but I won grand prize, which threw me all the way up to Intel ISEF in Pittsburgh, the international stage. And at the international stage, it was a wonderful time. It was a whole week. I got to meet people from ACM, the Association for Computing Machinery, and I actually won a first place award from them, also from the NSA, and also a grand award from Intel. And also, there's a paper being written for this. And so this kind of just goes back to the innovate to impact part of it, and also building up on believing in yourself. Everything is cumulative. Because the origination for this project, again, was around me. I was looking at my dad. He's driving. He doesn't look like he's going to stop for the red light. I have to tell him before he hits someone else or he gets a ticket. And so all this comes from around you, not from these incredibly difficult to read research papers or difficult to understand experts. It comes from you. And so that's where the white space identification comes. And then building on top of it, of course, there's a little bit of technical knowledge involved, but once you have the idea, the rest will come in a natural progression. So, for this one, what I wanted to kind of elaborate on was your relentlessness in improvement. Because here's the thing. So, starting from August, that's when you really need to start thinking about your project at the very latest, and then you need to go all the way to May, which is the final stage of the international competition. And so you need to go again and again refining not only your science, but also your presentation, because I can completely assure you that my initial presentation did not look like this. It was a single board. It didn't have a lot of clear information. I didn't even know how to pitch my idea. But by the time May rolled around, I was on top of it, and then there's just a whole lot of stuff that you have to do to ensure that your project is at the highest level. Because as other people say, a piece of art, and if you think about it, research projects are totally a piece of art. A piece of art can never be completed, it can only be abandoned. So you need to make sure that every time you look at the project, you need to have, I won't say perfectionist, but you need to have super high standards in order to make sure that you are above others, right? Or you make the product that can impact your community the most. So that was what I wanted to get across with this one. So after 10th grade, over the summer, I did a research project at the University of Texas at Arlington. And what happened here was I met this professor. His name was Dr. Shang-Kai Lee. Immensely smart, and he has some really awesome PhD students as well. What we worked on was something that Facebook cannot do. And when you look at it, you're like, come on, man, clickbait. What are you talking about? I'll explain. So Facebook, it's incontrovertible that fake news is a problem, misinformation. And what the university was working on, and it's a long research project, as many research projects are, it's a long-going research project that aims to combat fake news. And so this system has a couple of facets. First of all, let's just say you give it a sentence. You say, Donald Trump is the 51st president of the United States. An incorrect fact, but it is a fact. But if I tell you, Kevin ate 3 apples at lunch yesterday, it is a fact, but no one really cares. And there are also non-factual statements like opinions, Jonathan is super smart. You can't verify that without a specific metric for your interpretation. And so these are 3 classes. If you're familiar with machine learning terminology, these are your 3 classification classes. So once you determine which statements are important factual statements, you can then fact check against the database. But if you think about it, this is an incredibly difficult thing to do, to determine, given a sentence, and a computer has to do this, what exactly is important factual, what is not important factual, and finally, what is not even a factual statement. And so in this project, I worked with the PhD students and another group, and we developed this kind of process. First of all, using natural language processing techniques, we made the sentence more comprehensible to the computer to give it more information about the words that we're using. And then we transformed them into word embeddings, which allow the computers to, which adds another layer of understanding for the computers on these words. And then finally, a deep learning stage to learn these relationships to perform well. And so what we found when evaluating this was that it was superior to the state-of-the-art published in another Stanford paper. So we're currently trying to verify these results and then get a paper published and submit. So this is a really exciting experience for me, especially because I got to work with incredibly powerful hardware and software and incredibly great people. What you're looking at here is the command line interface for GPUs. A lot of people think of GPUs for gaming, right? NVIDIA GTX 1080 Ti's. I had 4 of them at my disposal. And of course, they're very good for training deep learning models, but I had access to state-of-the-art hardware, and we implemented state-of-the-art models and techniques, and we kind of innovated on top of others. So that was a wonderful experience. Now, what I've told you up to this point about this project really doesn't touch on the virtue I wanted to communicate with this one, because the virtue I wanted to communicate was immersion. You need to be able to immerse yourself in your work. I worked on this project over the summer, so around June I started on it, and then I worked on it all the way to the end of July. And so it's this kind of immersion, and a lot of people say this, they say, if you don't think about what you're doing in the shower, you'll never be able to do it well. It's a joke, but there's a certain element of truth to it. Because if you don't always think about your work, how do you expect to innovate to the highest of your capability, to innovate better than others can? And so, immersion is incredibly important. You have to find something that you're passionate about, that you care about, that you really can't go a day without thinking about, and that's where greatness will come. So, after this project, I worked on it until late July, and then in early August, right before school started, I don't know why Plano decided to start school so early this year, but in the first days of August, I went to SMU, Southern Methodist University down in Dallas. And what I did there was I worked under a professor in electrical engineering, Dr. Joe Camp, and what he was working on was drones. And drones have immense potential. You know, Amazon has been discussing using them for delivering packages. We've been talking about military applications for them as well, albeit with a little bit of controversy. But Dr. Joe Camp was working on drones that move as a group. So drones, Dr. Joe Camp wanted to apply these to a multi-antenna transmission system for wireless signals. So he would have drones arise in a group and move around in a very precise pattern and then transmit signals. But the problem with this is that these drones have to be, number one, very programmable for their path, and number two, very precise in their location, because just a little bit of difference in their distances can result in destructive interference with these waves. So he needed a system that was responsive. You know, they have to be maneuverable, extensible, which means you can build on top of it, you know, hopefully in some kind of code fashion, because that's how you can build most easily. And then we need it for autonomous applications. They need to move as a group autonomously or with human input, but autonomous flying is the goal. So we worked under Dr. Joe Camp. We built this hardware piece. We put the parts together. We bought the parts. We put them together. We soldered the wires. We assembled the drone, and then we did a little bit of programming to wrap it all together. And so what we found was our drone. Of course, it wasn't perfect because these things take years and years of experience and knowledge and refinement to perfect. But we were able to get a drone that was balanced quite well. It was quite precise in movements, and we could give it a path, and it could navigate around based on the GPS and inertial motion sensors. So it was a successful track, and Dr. Joe Camp is actually using this drone in his future research. So this project I wanted to expand on. What I wanted to expand on was expanding your domain. So prior to this, I came into this being mostly a software person, right? I like to do coding, I like to look at algorithms. But in this project, I was able to work on hardware. And so in the program, I met this guy, his name was Justin, and he really was a hardware enthusiast. He told me about all the little things that he built in his garage. Microcopters, he built airplanes, he's built cars. So he's built a whole lot of stuff, hardware stuff in his garage. And then so I was able to work with him. We were soldering wires together, we were assembling these, we were ensuring that the balance of the airplane, the craft, wouldn't make it tip over. So all these things together, we were able to work with each other. And so hardware is not the only thing that you can expand into, because there's a whole lot of other stuff. Biotech, electrical engineering, computer science. There's just a whole lot of places where you can innovate. And software, we cannot limit our eyes. We need to open our eyes to much greater applications of technology. So that was for this project. So remember that was right before my 11th grade year, which I am in right now. And so now we've arrived at the present. So the big question now is, what is next? And I have a few ideas. I've been working on this project. It's going to be due very soon. So I'm going to be working hard on it over Thanksgiving break. But just generally, as an introduction, we have 6 senses, right? We have eyes, ears, we have taste, we have touch, and we have smell, right? Those 5 basic senses. Now, I want to focus on sight. You can see light, right? They reflect over these walls, or they're absorbed by them, whatever. But the problem is that they don't go through these walls. Neither does IR, neither does UV. But what's interesting is radio frequency waves do go through walls. And what's interesting, not only like on a level above that, is that their interfaces with the human body and our properties result in very interesting behaviors. So they go through walls, but they reflect off of our own bodies. And I know that a lot of you are now thinking through wall vision. And that's a very, very interesting topic that we don't know if it's going to be viable or not, but that's exactly what I'm working on, and a lot of several other universities are also working on this. And so a potential application of this. We all know that about 2 months ago there was this horrible tragedy where 2 students were followed home by a person, and then there was an altercation that occurred, and then lives were lost. They were followed home without their knowledge, so the person entered the home without them knowing right behind them, and some kind of altercation occurred inside that I don't want to go into detail with. But this kind of radio technology, especially in the dark, you know, late at night, it can totally be a helpful element in not only seeing them through walls when they're potentially dangerous, but also in other applications, such as military, medicine and search and rescue. If you can see through walls, you can see the people behind debris as well. And so all of these combined, there are also many integration factors we could have. Vocal control interfaces with natural language processing units, basically another way to say Amazon Alexa, Apple Siri. All these things can be used to provide vocal commands to, so that you can provide input. And then you can also integrate this with Raspberry Pi, a popular kind of DIY tool that you can use to capitalize on these actions that are provided, this information that is provided by these radio frequency signals. And so ultimately what this results in is a whole wide range of possibilities. Just one example. Let's take a military example. We are breaching some kind of compound. We don't know who's inside. We don't know what position are they in. Are they in offensive position or are they just sitting around? So all this information results in breaches being an incredibly difficult and dangerous action for these military personnel. They don't know who's inside. They don't know what they're preparing to do. They don't know what kind of damages are possible. And so with this kind of technology, you go in, you see what they're doing inside. You not only know that there are people, but you also know what they're doing, what kind of poses they're holding. And so from this, you integrate that, I don't know, with drones, with vocal control units, with Raspberry Pis, with your weapons, with your defenses, all to produce a much safer military action plan. So this is just one of the many, many possibilities that we can have with this kind of technology. And so that leads into what I want to say with this. Now, even though I don't have many details on it, that's exactly why I said dream big. And that's exactly what this is. It's a dream. But there is really, really nothing that humans can't do with just minor exceptions. And even if we can't achieve our dreams, when we land short of them, we're very close to where we wanted to go. Because a lot of the things that we thought were completely impossible, like my mom was talking about how when she left China, she would be very sad because she could never see her mother's face for another many years. You know, what if I could just pull up a screen and see her and talk to her? FaceTime, WeChat, video. And so all these dreams have now become reality, and dreams are really what push us forward. So really grasping these big dreams is what innovation is all about, to address a problem in our society. And so with all these 6 projects, we've come up with 6 core virtues. Innovate to impact, believe in yourself, relentlessly improve, immerse yourself, expand your domain, and dream big. I want to split this into kind of 3 categories. In the first project, I kind of established a purpose for innovation, right? You don't innovate to impress people, you don't innovate to gain fame, you innovate to make a difference. And then an attitude. What happens when other people don't validate you? What happens when people don't think your idea is going to be useful, is going to be applicable? That's when you need to believe in yourself, and then you need to adopt this attitude of relentless improvement. Because only through this can you really improve your project, your idea, your innovation up to the level that you want it to be. And then these last 3, on a little bit of a more tangible note, not really, but in terms of execution, you really need to enjoy what you're doing. Immerse yourself in it. If you don't like to do it, figure out why and make yourself like it, or switch out. It's totally fine either way. So you need to always think about what you're working on. You need to expand your domain. Don't close yourself in one area. Because interdisciplinary studies, these multidisciplinary innovations are really what can finally impact everyone. And if you think about it, all these innovations are all interconnected with each other. Even the humanities, these social sciences, they have immense implications in the development of artificial intelligence systems, because who are artificial intelligence systems serving? People. And then finally, I want everyone, including myself, to be able to dream big. Thank you.
Thank you, Kevin. Very exciting, right?
Oh yeah, I'm excited. Oh yeah. You know, can I one more point? You know, to him.
Okay, yeah.
Basically, you know, I had one point that I didn't mention. You know, basically I have one point right here. Basically, in the future, I dream that people, human being would have like 4 eyes, 2 eyes in the back. So basically, we are gonna have like 360 view, in the future. Plus the see-through, technology with you. It's gonna be everywhere. So in the future, we can add arms to our body. 我们可以加上手臂、手脚都是可以的。It's awesome. It's a great idea. Wow.
That's why our president, they began to present the award to us. Yeah, Kevin.